Today we'll be looking at the differences between corrosion and lamination during the proximity test. This differentiation is very important when you are trying to perform fit job and you need to be sure if the indications you are seeing, maybe you are looking at the pipeline, you are looking at the pressure vessel, and you are trying to determine whether the indication is a corrosion, which is a service-induced defect, which is what we are looking for, as compared to lamination, which is a manufacturing defect. So basically, you should be able to, as an inspector, to differentiate both of them because if you don't, you end up calling the lamination a corrosion, and that will lead to a lot of waste of dollars. So we're going to look at the amount to differentiate them as we proceed. Now we are going to look at corrosion and lamination. What is the difference? So conceptually, we will start with how both of them are formed. For lamination, basically, is a manufacturing defect. So let's say we have during manufacturing a big block like this that has some inclusion or void. And then during rolling, now if we roll this through during manufacturing to get a flatter plate, I will take this through this block. We are going to get a flat plate. And these voids that are irregular in shape, they will now become flat. This is now our lamination. On the other hand, if you look at corrosion is basically a form of a wall loss. So let's say I have a plate and I have a section of the back wall that has worn off either as a result of a chemical action or oxidation or rusting or whatever the form of corrosion. So this is corrosion, how it is formed. For lamination, for the functionality of this plate, for the application for which the plate is being put to use, the lamination does not have any effect on it. It does not affect the working pressure or any of the condition of the plate. So we are not really interested in lamination as a service defect. But if you come to corrosion, looking at this where you've had a substantial wall loss, definitely this becomes a weak spot and the plate can fail from this point. Can even lead to reduced pressure if you want to continue using this plate. So as a UT inspector, the idea is for you to be able to differentiate this lamination as compared to corrosion because for corrosion, it will be causing a significant issue with the whatever application you are putting this plates to. Now, if you look at the difference now, if I put a probe here, if I put a probe here, and we send the ultrasound in, it gets to the lamination and it's reflected back. Typically, we are going to have an indication coming from the lamination. Now, if I put this same probe on a good area, let's say this area does not have any form of lamination, it gets to the back wall. It is reflected back. This will form this will form our back wall echo, and in this case, this is our lamination echo. So the first major difference between a corrosion and lamination, when you have a lamination, the lamination echo comes sharper and the amplitude is longer than the back wall echo. But if you look at corrosion on the other hand, if I have, of course, similar scenario, if I have my back wall, it comes flat. This is my back wall and go. If I put this in probe on the corrosion end, it will give me a smaller indication compared to the back wall. So if the back wall is longer, the corrosion, so this is corrosion, corrosion will give a much more smaller amplitude echo. Why is that so? If you look at the way the shape of this, if the sound beam comes to this point, what happens? It gets scattered. So it's only a small portion of it that goes back. So typically a corrosion echo will have a smaller amplitude. So one major difference is the lamination will have a longer echo in terms of amplitude compared to the back one, while corrosion will have a smaller echo. Echo with small amplitude. The second difference between corrosion and lamination, if I have a lamination here, I can have multiple lamination. So I can have lamination back wall, another lamination back wall, and it repeats. Though when you are at the center of the lamination, this back wall may be eliminated because in this case the echo is not getting to the back. But at the boundary between the corrosion, the lamination and the back wall, so you can have a portion of the echo coming this way, or the ultrasound rather coming this way, and the other one going to the back wall. So you have your lamination echo and you have your back wall echo. But if you come to corrosion, it is very difficult to have multiple corrosion signal. And in most cases, when you see a corrosion echo, this back wall will be eliminated. Obviously, you can see because when you are at the middle of the corrosion, there is no back wall. There is no back wall to get any indication from. So when you have the corrosion echo, most times the back wall is eliminated. And it's very difficult to have multiple back wall of the corrosion because at the end of the day, the amplitude would have gone up. So first difference, lamination has a longer echo compared to the back wall. Corrosion has a smaller. The second difference is lamination has the ability to repeat itself. It produces a clearer, sharper echo, so it repeats itself, but corrosion does not repeat easily because a lot of the ultrasound is scattered. The third one is most times when you have a corrosion echo, you are not going to find the back wall. Take note, both of them will usually come before the back wall, but in case of corrosion echo, you rarely find the back wall echo. But lamination, at the boundary of the lamination, you are likely to see the back wall echo. So these are basically the differences between corrosion and lamination. You cannot miss it. So we are going to now look at practically how to differentiate between corrosion and lamination in plates. Now, if you look at these plates, typically you will have the back wall echo. You can see the position of the back wall. If there are no issues, the back wall will always come at that point. That point you see it. So if I continue to scan around this plate, at some point, this is what I get. You know what I said before, this is a typical back wall echo. Now, if you look at the boundary between this is the back wall echo. This from our explanation, you see that this is our lamination echo. It's way sharper and has a longer amplitude than a back wall echo. This is the lamination echo repeating. Now, if you look at the back wall echo, this is the back wall echo. Now, this is the lamination echo. You can see the difference. And at the boundary between the lamination and back wall, you see this is your back wall and this is your lamination echo. Very easy to differentiate. Now, if I come to this one, this is my typical back wall echo. This is my, if I scan around, this is my typical back wall echo. But if you look at this point, you see a much more smaller amplitude echo that is still coming before the back wall echo. However, the way you look, you see this back wall is here. Now there is no back wall. Now you can see that when the corrosion echo is there will be no back wall. And the corrosion echo does not repeat itself as compared to this is the lamination echo that is repeating. You can see how it repeats clearly. But when we come to the corrosion echo, it does not repeat. So with this, you can clearly differentiate between a corrosion echo, which you can see now smaller than compared to the back wall, smaller compared to the back wall, and it doesn't repeat. Even if it does repeat, the echoes will be very small that you can't even clearly define it. However, if you look at the lamination back echoes, you see them repeating and high amplitude. That is just basically the differences. The measurement and mapping of the corrosion and lamination and the depth is a different story altogether.